Welcome back everyone to Data Science for Everyone. Today we're going to be talking about NumPy. Let's get started then on actually talking about NumPy. So NumPy itself is a linear algebra library for data science. It is fast, and that's because in the background it actually runs the C programming language. The way that we access this is going through and using import NumPy as NP. And it has a ton of functionality that we can use. Okay, so it's predominantly, again, like I said, a linear algebra mathematics library. So, and it is used, again, the big portion of this class, we're going to be using the pandas module. But what we're actually going to be doing is a lot of times to run faster calculations, we're going to be using NumPy to run those calculations. Now, NumPy uses arrays. So an array is a matrix, okay? It's a vector. It is, we can do this as a one-dimensional arrays, 2D arrays, or ND arrays that can be very, very large. That can be very, very, very complex. Now, I'm going to go through, again, just the basics of what this is, and the more we go through the course, the more advanced topics we'll start to kind of look at. But first is if we look at just making a list, okay? So in this instance, I'm just making a numerical list, 1, 2, 3, and then we can convert that using this NP. So again, we imported NumPy as NP. This is its alias. And we convert that to an array. Now, if you notice, it didn't really change anything, okay? It gave us this word array, and it still gives us back this list. Now we can make a matrix, okay? So a matrix, let me pull up a writing tool really quickly. So I can do some annotations here so you can see what's going on. So an array usually is something like this. So we have maybe y1, y2 to y, maybe let's say n, okay? Now, if this is a vector, all right, and it's something very similar to like a 1D array or very similar to a list. Now, we also have a matrix. So a matrix, if you notice here that it has multiple lines inside of a list. So it's like a nested list, a list inside of lists. Now, if we draw this way, we get this. So it would be something like x11, x12, x13, and we'll just do a 3 by 3 for now so that you can see that. And we have here, so x21, x22, x23, and then finally we would have something like x31, x32, x33. Now you can think about this in this instance, that this is, and what we would normally call as features. Okay, and you can also think about this as if you were using an Excel spreadsheet. Okay, so this is also, we can also call this a table. All right, and so when we convert that, we would use this np.array. Now there are actually built-in methods for matrices as well, but if you notice that this still holds the shape that we had here. So this would be a 3 by 3 matrix. So it also has some nice built-in methods. Okay, we can use a range. So this would allow us to make a lot of, to move this out of the way so it's not. There we go. So now when we use this np.arange, this is actually creating a range of numbers. So here we're going something from 0 up into 9. Okay, so this works, this is similar to the range function in pure Python. Now we can also do it so that we want to maybe move it by 2s, so we go 2, 4, 6, 8, so we want to grab all even numbers. So we can run these again just to show that they do indeed work. Now, another thing that we have a lot of times to want to be able to do when we're doing linear algebra, matrix algebra, those types of things, is we need to be able to create a vector of zeros or a matrix of zeros or a matrix of ones, or we need to create identity line spaces, those types of things. And NumPy has that ability. So if we just give it some number, so here we do np.zeros.3, it will give us a vector of 3 zeros. Now we can also do this as something like 100, and it will give us a 100 zeros inside of a vector. And again, a vector is that kind of 1 by n vector space, that line. Now we can also give it, if we want rows and columns, okay, we can give it a tuple in here, which is represented by the parentheses. And it, for example, you want a 5 by 5 matrix here of zeros, you can do that in this way. So I'm making it 5 by 5. We can do it by, I don't remember if this one allows uneven, but yeah, it does. So this can be a 6 by 5 as well. I'm going to go on and change that back to 5 by 5. We can also, as I said, just similarly to the zeros, we can have ones, okay? And so then this allows you to have like a scalar matrix or a scalar vector. And I'm going through this relatively quickly because I know that you guys had some linear algebra in your previous classes, so I expect that you guys can kind of follow along with this a little bit. And let's go back to now doing a line space. So the line space is actually very similar to using like a range, but it has this ability to say, like, I want 3 numbers between 0 and 10, and this is also up to and including 10, and you want them to be evenly spaced out. Okay, so if we want something from 0 to 10 evenly spaced in 3, well, we get 0, 5, and 10. Now you can also do this. I want a nice line space, everything from 0 to 10, but I want it by 50s, and this will cut up starting at 0, going all the way up to and including 10 into nice little chunklets for you. And this is great whenever you're wanting to maybe create a fictitious data set or something like that, or you want it to be able to run around in to be able to give kind of an example whenever you're working with your employer. Also, we have the ability to do an identity matrix. So an identity matrix is just a matrix with ones going down the diagonal, and we use this for a lot of matrix calculations whenever we're actually doing the mathematics. This would come into play a lot more in when you're actually wanting to do maybe eigenvectors, those types of things. We can even calculate the eigenvectors and eigenvalues as well than what we've had previously. But all you need to do here is put in whatever number, and it will make a complete identity matrix. So I can still put in here like 10, and it will give us 10 by 10 identity matrix. And then I don't know if you guys you've covered that before, but a lot of times we just represent this with a capital I. Okay, and it would maybe say we could have I under subscript 10 here for it to be a identity matrix of size 10. Now, a lot of times we will also use the NumPy random. So you can grab two. So NumPy imp.random.rand would give you some random digits, okay, 2 random digits. Or so, for example, if you want them to be, if you want 10, you can do 10 random digits. Now this will be a uniform distribution, okay, between 0 and up to 1, but not including 1. And you can also do the same thing for a matrix. Now this is a little bit different than what we used when we were using the array function. Okay, notice here that you want a 5 by 5, you just do 5, 5, and this will give you a 5 by 5 matrix of random digits between 0 and 1. Now we can also use the RandomInt, okay? So this will basically return a nice standard normal distribution, and so it's different than the instead of the rand. So notice here there's a little bit difference here. There's the rand, all right, just with a D, and there's the RandomInt. Okay, in here is specifying normal for normal distribution, and this will also allow us to grab randomized subsets and samples. Then we also have the RandomInt. So, and this is allow us to create, again, this low to high value of just a random integer. And so then we can also do something. So we want a random integer between 1 to 100. Okay, this would give us some random integer. And again, anytime we run this, it will give us something random unless we set the seed. And I'll talk to you guys about setting the seed later on. But this is always important for us to be able to generate these random. Sometimes we want to generate random noise into a model to allow us to look at a little bit of, again, given that fake noise type values if we so want to. So we can also do, if you add in one more variable or one more argument in here, you're able to make it so you have the number count that you want. So not just a single integer, that's its default, is setting it to 1. But if you want 10, you want 100 random values, you can. And if you notice here that it is possible for there to be potential repeats. But let me move that back down to 10. Now, let's start talking a little bit about array attributes and methods. This is more or less what I'm wanting. This is kind of the meat of what we're going to be talking about today, because a lot of these skills from NumPy are going to move over to when we start utilizing the pandas module. So one thing that we can do is let's grab an array of random integers. Okay, and so we can, again, notice that we can save these, all right, in variables, just as we can with any other type of object in Python. Now we have two of them right now, okay? We have one that is just 25 random numbers, then we also have a random integers. We want a vector of 10. Now we can utilize the reshape method, okay, to compress it into the shape that we want. So again, we have to make sure that it actually would fit into that shape. So if we tell it here we have 25 random numbers, and we want to put it into a 5 by 5 shape, then again, we will have 25 digits in here. So let me make one that's also, let's call it R24 equals np.arange24. Let me rerun that. And so if I take this and I go arrange 2024.reshape, and let me just say that I wanted a 5 by 5. What it'll do is it will give us an error here, and this is a very common error that you guys are probably going to pop up with in the future, is that you are trying to reshape or clean a matrix or edit a matrix, and it's going to say, I can't do that because of the number of values that I have cannot be in a 5 by 5 shape. Okay, it's going to be a mismatch. You can't put 24 numbers into 25 sections or item values. So along these lines, okay, reshaping is going to be relatively common when we start getting into more machine learning aspects of data science, particularly when we start looking at our predicted values. Sometimes they'll want to come out as a matrix, and we need to reshape them into a vector. Or sometimes they are maybe in a 2D vector and we need to reshape them into a 1D vector so that we can have that data a little bit cleaned up and a little bit more readable. Now, the next is just basics of max, min, argmax, argmin. Now, what we utilize with these is being able to grab our numbers. So for example, you guys understand how max works. So I want to find inside of this array, I want to find the max value. Well, that max value is 49, so it will grab that 49 out from our vector. Now, what's also very useful for us is to be able to find the location of 49. Okay, so in that instance, let's say we want to find the argmax. Now, argmax says that it is at index 4. So if we go 0, 1, 2, 3, 4. All right, so that tells us the location of the max value. And again, we can do the same thing with the min and the argmin. Now, we will use these sometimes when we're wanting to optimize functions or we're wanting to find the optimal value. Okay, so just be aware that there's a difference between max and argmax. So if you want the location, check for the arg, all right, arg. If you want the actual value, you would cut off that arg. Now, these are, okay, if you've noticed, and this is something that is a Pythonic type thing, is that if you notice that these are all methods. So I have my actual objects here is the array, my array 24, my random array as well. But if I add on this dot method here, this is an actual method. Anything that's tacked onto an object with a dot is going to be considered a method. Otherwise, we would have a function which wraps around that object. So if we go back to our shape, okay, so now these are attributes, they are not methods. An attribute, so if you notice here, this method has these parentheses at the end here, okay, but an attribute does not. It's just kind of data that is embedded inside of our argument. So we can grab the shape, okay, so if we run this, we see that this is a vector, okay, so again, it is a 25 by 0, so it's only just 25 long, so this is 25 rows. Now if we look at and we want to reshape this, we can say that we want it to be a 1 by 25, and this is using our reshape method, and this will give us a little bit different format. Okay, notice here that it has 2 brackets, okay, and this changes the shape that it is now a 1 by 25. It actually changes the shape itself. This is 25 rows. This is 1 row with 25 columns. And so here, if we double check with our shape, we can see that as well. Now we can also change this, change the shape to 25 by 1 instead of 25 by, notice here, 0. And we get that each of these are in their own arrays individually. Now we will be using this again with more predictive models when the data, the predictive algorithm itself requires that the data be in this type of format. It just depends on the creator of the package and the model at what type of reshaping we need to do. Now, another thing that we can do is we can have a D type. So we can say what type of an array it is. So for our arg array, it actually is a D type int64. Sometimes we want them to be strings. Sometimes we want them to be booleans. It'll also help us with when we're starting to use pandas, it'll help tell us what type of data we're actually looking at. So the next part of this is being able to use indexing, and so that we can do selection. So if we create another array here, and we want to look at using bracketing. So this is the same as and similar to using lists in Python. So if you want to be able to grab a specific item, okay, inside of here, you can use bracket notation. So for example, you have to give it by its index value. So here, for example, I want the value, I want to grab whatever is at 8. So let's see here at 0, 1, 2, 3, 4, 5, 6, 7, 8. Now notice it just so happened to be 8. So, but I grab that, it pops out, and we want it to be 8. Now we can also grab a slice. So this is called a slice. And so we want something to start at 1 and go all the way up to, but not including 5. And we can see here that it gives us an array back of 1 all the way up to, but not including 5. So we get 1 to 4. And again, we can also do the same thing if we want to start at 0. Again, we've talked about this, and we've seen this before in the videos that I gave you guys about lists. So all of this is the same as that. Now, there is a double-edged sword that we're going to talk about, and this is broadcasting. Now, what we can do here is take one value or an array of values, and we want to overwrite them. So for example, here we can take the value of 100 and say we want all the numbers from 0 all the way up and 2, but not including 5. And notice here what happens. It overwrites all of those values. Now, another thing that we can do, though, again, this is useful if you want to do this. You want to maybe change up values, but you can also do this with a slice. Now look, I will notice something. This is our new set. I'm going to reset the array, and it's going to start at 0, go all the way up to 10. Now, I'm going to save a slice. Okay, I'm cutting up a slice from 0 to 5. Now, look what happens. I want to change all of these values of slice, okay, to 99. Okay, they are all 99, but then we're going to run into a problem. When we run our array, look what happened. These are 99. Notice we have not been touching array here at all. But what happened is the array that we talked about here, where we made our slice, is still there. So what this did is it has a pointer. So if we talk about it in a way of memory, okay? So we created this array function. Now we took a piece of it and we made this slice, and then we overwrote, and again, remember, this is only maybe a piece of it, and we overwrote this with 99. But what happened is that this is still pointing towards our array. And so it overwrote all of that little chunk that we had there. So this can be extremely dangerous. That's why and that's the next point that I'm coming to, is always to make copies of your data before you do any implementation. We will do this a lot when we start using with pandas. We may import a data set, but then we will make a copy of that data before we start working on it, because we do not want any broadcasting behavior back to the data set. Now, you may be asking, why is this important? That doesn't seem like it would matter a whole lot at just a small data set. But if you are linked up to the database of your firm, and let's say that you accidentally overwrote 1 million rows of customer data, then that data is gone. Okay, so this type of thing is very, very important, and it can be extremely dangerous for companies. That's why you need to make sure and always restrict people's access to the data, and also always make sure to be able to clean up and deal with data in the proper manner. So that's what we'd be looking at when we use this copy. So if we use this .copy onto an array, this method, it has to be explicit that we say this. It will make a proper copy, and then we can edit. So let me go in and edit this one like we did before. So I would want maybe slice of an array, and we're going to make this 2, and array copy, and I want from 0 to 5. And then I want to look at changing slice of array 2. Okay, so this is, notice something. This is our copy. Okay, this is what should be in there. But we also have our array here, which is also a copy of that. So now if I change, let's just look at it real quick so I can show you. Whoops. That's because I didn't run it. There we go. So if you notice here, now it's 999, and I want to change this slice of copy 2. Let me just change the whole thing to equal 100 or 1,000. So now if we look at the actual value in here, everything is 1000s. If we take a look at our array copy, notice it is going to be the 1000s, but if I go back to our array that we made the copy of, notice they are now 999. Okay, so this is a way to protect yourself. It gives you, using the copy method gives you a buffer between your original data set and the copy. So hopefully you guys will start to get used to being able to utilize copies in the future. And so now we're going to move on to utilizing matrices and how we actually grab a hold of data. So if we have a 2D array, we would have this. We can actually access the data in 2 different ways by using this row column format. Now I recommend using this version, okay, for clarity's sake. That's what I'll be using a majority of the time in the class. So let's grab and let's create a new 2D array. So this is a matrix of several different numbers. Now if we want to grab the first row, okay, we would grab this, our array name, with a square brackets 1, and this will give us our first row. Now notice though, it's 0, 1, 2. Okay, so 0 would be our first row, but row 1 is technically this middle row here. Okay, so always be cognizant of how that is actually working. Now if you want to grab, for example, from row 1, you want to grab maybe 20. Okay, you have 2 different ways to do this. You can use the double bracket notation, like so. Okay, and this would grab the 20, but again, you can also grab it via the individual element being 1, 0, and this will give you that element as well. So if we grabbed row 1, value 0. Now if we wanted to grab, let's say 45, okay, we would grab, and I'll show it with both ways here. We can grab 2 by 2, and this gives us 45, but at the same time we can also do 2 by 2, and this will also give us 45. All right, so let's go on to our indexing, our 2D arrays and our matrices. Now, we can also use slices inside of our bracket notation. So if we want to grab, for example, if we go back here and we want to grab this subset here of maybe these 10, 15, 25, and let's say 30. We can go through and utilize our bracketing notation. So we want from 0 all the way up to 2, not including 2, and we want to start at 1, go up to the end. we can grab that subset of cells inside of that matrix and those items inside of that matrix. And this would be useful for, again, if you're wanting to zero in on some observations to take a look. And again, there's also different types of mathematics that we can do with that as well. And again, we can, if we follow the same type of shape, we can also grab specific rows and, whoops, don't want that to happen. We can grab, for example, we want to grab the bottom row, okay, would just be 2. But if we also, we can also do that, that's the same way as using this comma colon. Now the comma colon in this instance just means to grab all. We also are able to do some fancy indexing. Okay, so if, for example, we want to set up a matrix of zeros and we want to reshape it, okay, or grab just the shape of that one, and then we can actually set up an array where we do something very fun. Well, I said fun, show it to me. There it is. So then we can have, we can make something that's like each row is 1, 2, 3, 4, 5, 6, all the way up to 9. And this is a very, I usually do this just as a way to kind of show you guys how the indexing actually works inside of Python. So what this is doing is it's grabbing each of the indexes for each row and telling you where that is located. So if you have this 10 by 10 matrix, you have the row starting at 1 and it goes all the way up to and including 9. And notice the double brackets here at the ends to let us know that it is a 2D setup. Now, a little bit more on fancy indexing. You can grab and use a bracket notation. So you can put in a list of ID locations and it can grab those out for you. So for example, you can grab 2, 4, 6, 8, and if you notice, we're grabbing each of the rows 2, 4, 6, 8, and it's keeping them for us. Now you can also reorder them as you see fit for the rows, okay? And so, for example, if I want 6, 4, 2, and 7, it will replace those in that order that I like. And we will be using this a lot in our pandas series after this in order to reorder our columns so that they're in an order that we like, and to really be able to drill down into some of the different types of data that we have. Now, we can talk about a little bit about some selection. Now this is, again, this is very similar. We're basically doing numerical operations. What we're able to do with this is use this greater than, less than, equal to, all of those types of things like we did with lists and numbers, and are able to create here, for example, look, this is a Boolean expression. Now we can use this with our selection tool. Okay, so we can make a Boolean array. And so inside of here, so if I wanted to grab this array, and maybe again, right now it's only 10 numbers long, but let's say that it was 1,000,000 long, a trillion long, it could be just this massive data set, okay? And you wanted to grab every number that was greater than 4, okay? You can use this greater than 4, create a Boolean mask, and then when you run this with the Boolean mask, it will only grab out those numbers that are greater than 4. Now this is a lot, you can also do this just by using the actual numbers inside of here. You do not have to create a mask, but I suggest creating a mask because when you're starting to try and debug longer segments of code, it's very easy to find, for example, that this was my mask. Oh, that I had an issue with my mask here, and it created problems for me down the line. Whereas if we're writing everything in here, it may be a little bit more difficult to parse out what the issue is. Furthermore, we can use variables. Okay, so if you want to test out multiple examples, so let's say everything that is greater than 2, oh no, I wanted to check it, everything that's greater than 5, and then you can rerun this over and over again to check and see what values there are. In later series and lectures and stuff, we can also go over eventually maybe how to make a user interface so that, for example, you make a dashboard for your manager or for your boss or for yourself even, and you say, oh, well, I want to find all of the values that are utilized here, and you're able to input your own methods in there to kind of drill down and search what's going on. Let me see how much more we got here. All right, so this next part here is looking at NumPy operations. Now, you can perform arithmetic using scalar values all you want. I don't know why I have so many of these here. All right, so what we can do, you can add two arrays together. Now, this is where they start to differ from lists. Notice here it basically doubled everything. Okay, because if let me put in so you guys can see what the actual array is. It goes from 0 to 9, and again, if you add them together, they're going to double. Okay, if we use the plus sign with lists, it concats them together and it links them together. Now, if we use the multiplication, it actually multiplies them across. If we subtract, it subtracts them across. Now we are going to have a bit of an issue here, though, if we try and divide them. Okay, because we get a divide by 0 error. Okay, now it does try its best to help out, and it says that it'll give a NaN value otherwise, but it's because we have this 0 in here and we're trying to divide by 0. That's impossible. So basically, to keep the universe intact, it's going to give us this nice warning message. And we can also say that we can set divide by we can allow divide by zeros, and we would just put this NaN value in there for us. That happens more often than you think. So just be wary that you know that this is the error that will actually come up. It's usually a runtime error. And the same thing is if we divide all of this by 1, because again, if we get this infinite, again, it's this divide by 0 instead of error in here as well. Okay, so just be wary that that's there. We can also do multiplication. We can also, well, we've done multiplication. We can also do exponents as well. Now there are some universal functions as well. So for example, the NumPy square root. Now we do have the math module as well that has square roots in it, but for this series in this class, we are going to be sticking strictly to using NumPy because again, it has that C backend and is much more efficient for what we've been using in the past. Let's also go and look at some of the more other universal functions just as before. So this here we're doing exponential. So for example, e to the some number. So e to the 0 is 1, and then again it's going to go on and solve that for us. We also have np.max, all right, and so that's the same as array.max. We also have here sine, cosine, log. Now we will be having an issue here because again, using the natural log of 0 is going to give us negative infinity. So just so that you guys know that this is kind of all the basics that we're going to cover from NumPy for this series that I'm working on here. And then the next up is we'll start talking about pandas and pandas data frames. So if you guys like this video, please make sure to subscribe and drop a like down below, and I'll see you guys next time. Bye-bye.